Dear students, good evening. Today we are going to discuss about how can we calculate the angle between two surfaces. That is the concept. Using these concepts, how can we find the value of the unknowns A and B? That is the concept today. But in your lower classes, in your 11th and 12th standard, already you have studied about the same concept in a different way. So I am raising one question now. The question is, how can we say, suppose we are having two vectors A and B, how can we say whether the two vectors are orthogonal or perpendicular? At the time, what is the condition we are having? That is my question. At the time, vector A dot B vector is equivalent to 0. The dot product between two vectors is equivalent to 0. At that time, we can say the two vectors are perpendicular or orthogonal. So here, see our concept today. Here we are having two surfaces. Let us consider the first surface is phi 1 is equivalent to ax cube minus by squared z is equivalent to a plus 3 into x squared. This is my first surface, and consider the second surface phi 2 is equivalent to 4x squared y minus z cube is equivalent to 11. This is my second surface. Now, what is the condition for finding the angle between these two surfaces? So, first we are having one formula for finding the angle between two surfaces, that is nothing but cos theta is equivalent to del phi 1 dot del phi 2 divided by modulus of del phi 1 into modulus of del phi 2. That is the condition for finding the angle between two surfaces. But what is the condition here? We are having may cut orthogonally. At the time, two surfaces. So, del pi 1 dot del pi 2 divided by modulus of del pi 1 modulus of del pi 2 is equivalent to cos theta. In our given problem, we are having the two surfaces may cut orthogonally. That's why the angle is nothing but 90 degree. At that time, left hand side is nothing but cos 90 degree. Cos 90 degree. What is the value of cos 90 degree? 0. At that time, what is happening now? 0 is equivalent to del pi 1 dot del pi 2 divided by modulus of del pi 1 into modulus of del pi 2. At the time, what is the condition we are having there? Cross multiply this, automatically we are having del pi 1 dot del phi 2 equal to 0. That is the condition we are having. Two surfaces may cut orthogonal means, what is the condition we are having here? Del pi 1 dot del pi 2 is equivalent to 0. It is from cos theta is equivalent to del pi 1 dot del pi 2 divided by modulus of del pi 1 into modulus of del pi 2. This is the formula for finding angle between two surfaces. But here in our problem, already they mentioned the two surfaces may cut orthogonally. That's why the angle is nothing but 90 degree. So cos 90 degree is nothing but 0. So this formula becomes del pi 1 dot del pi 2 is equivalent to 0. Let pi 1 is equivalent to ax cube minus by squared is z minus of a plus 3 into x squared. Let us consider our pi 1 is nothing but this. So first of all, we have to calculate del pi 1. Right? Del pi 1. What is the meaning for del phi 1? Gradient of the surface phi 1. What is the formula for finding the gradient? Del pi is equivalent to vector I into dou pi by dou x plus vector j into dou pi by dou y plus vector k into dou pi by dou z. This is the formula for finding the gradient of the surface, right? Gradient. So the surface is nothing but pi. So the del pi is nothing but, the formula is nothing but this. So del pi 1, here we are having two surfaces, that's why we denoted the first surface is pi 1. So del pi 1 is equivalent to, what is the formula we are having here? Vector I into dou pi 1 by dou x plus vector j into dou pi 1 by dou y plus vector k into dou pi 1 by dou z. That is the formula with respect to first surface. So vector I into dou y dou x of this one, ax cube minus by squared z minus of a plus 3 into x squared. This is vector I into dou by dou x of this plus vector j into dou by dou y of, like the same. What's that? Ax cube minus by squared z minus of a plus 3 into x squared. Right? Plus vector k into dou y dou z of ax cube minus by squared z minus of a plus 3 into x squared. So what is the meaning for this one? That is equivalent to vector I into dou by dou x of this much. Upon differentiation, partially differentiate with respect to x. Upon ax cube, differentiation is nothing but 3ax squared. Here we are not having x term, that's why automatically that becomes 0 minus, what is we are having here? A plus 3 into 2x. Am I right? Because a plus 3 is a constant, x squared, the differentiation of that is nothing but 2x plus j vector of dou by dou y of, here we are not having any y term, so automatically that becomes 0. Here we are having y term, so minus 2by z. Next term also we are not having any y term, so the differentiation is nothing but 0 and plus k vector of dou by dou z of. So here we are not having any z term, so first term becomes 0 minus by squared, because the differentiation of z is nothing but 1 and next term we are not having z term, that's why automatically that becomes 0. The differentiation becomes 0. Now del pi 1 is equivalent to I vector of this much plus j vector of minus 2by z plus k vector of minus by square. In our problem already we are having the pointer. Now we are going to calculate del pi 1 at the particular point. The point is nothing but 2 comma minus 1 comma minus 3. So in our del pi 1 we have to replace the value of x, y, z by 2 minus 1 minus 3 respectively. So del pi 1 at the specific point 2 comma minus 1 comma minus 3 is equivalent to I vector of 3ax squared. So 3a, x value is nothing but 2. So 2 squared, that is nothing but 4. minus of a plus 3 into 2 2s are, again the value of x is nothing but 2, so 2 2s are 4, right, plus j vector of minus 2, b value is nothing but, b is nothing but constant, y value is nothing but minus 1, z value is nothing but minus 3, minus 2, b, y value is nothing but minus 1, z value is nothing but minus 3, right, plus k vector of minus b y square, so minus 1 the whole square. So what comes? I vector of, so 12a minus 4a minus 12 plus j vector of minus into minus plus, so 3 into minus 2 minus 6b j vector plus, here we are having minus into minus plus b k vector, right. So that is equivalent to I vector of 12a minus 4a becomes 8a minus 12 into I vector minus 6b j vector plus b k vector. This is the value of del phi 1 at the point 2 comma minus 1 comma minus 3. This is the value of del pi 1 at the point 2 comma minus 1 comma minus 3. What is our next calculation? As per the same, we are going to calculate about del pi 2. So what about our pi 2? Let us consider pi 2 is equivalent to, right, 4x squared y minus z cube minus 11. So now we are moving to find del pi 2. So how can we find del pi 2? Vector I into dou pi 2 by dou x plus vector j into dou pi 2 by dou y plus vector k into dou pi 2 by dou z. So as usual way, we are going to find del pi 2 and del pi 2 at the point 2 comma minus 1 comma 3, right. Therefore del pi 2 is equal to vector I into dou by dou x of 4x squared y minus z cube minus 11 plus j vector into dou by dou y of the same, right, 4x squared y minus z cube minus 11 plus k vector into dou by dou z of, like the same, 4x squared y minus z cube minus 11, right. Therefore del pi 2 equal to, del pi 2 is equal to vector I into dou by dou x of, so what, x square, differentiation of x square is nothing but 2x, so 8x y, so this also be 0, this also be 0 plus j vector into dou by dou y of, so differentiation of y is nothing but 1, so here we are having 4x square, remaining two terms become 0 plus k vector of dou k vector into dou by dou z of. So first term becomes 0. Here we are having is minus z cube. That's why the differentiation is nothing but minus 3 z squared. Automatically the next term is a constant. That's why the differentiation of the constant term is nothing but 0. So minus 3 z squared. So now we are going to calculate del pi 2 at the point. What about our point? 2 comma minus 1 comma minus 3. So I vector of 8 into 2. 8 2s are 16 into minus 1. So minus 16. Am I right? 8 2 8s are 16 into y value is minus 1, that's why minus 16 plus j vector of 4x squared, that's why 16. 4 already 2 squared, that also be 4, 4 4s are 16 minus k vector of, here we are having one minus, that's why here I put minus k vector of 3 into z squared, minus 3 the whole square, that is 9, 9 3s are 27. So we can easily write this minus 16 into I vector plus 16 j vector minus 27 k vector. This is nothing but del pi 2 at the point 2 comma minus 1 comma minus 3. Is that clear? Right. So del pi 2 at the point 2 comma minus 1 comma minus 3 is nothing but minus 16 I vector plus 16 j vector minus 27 k vector. Now in our problem, what is the condition? We are having two surfaces may cut orthogonally. Already I taught you the formula is nothing but del pi 1 dot del pi 2 equivalent to 0. So del pi 1, already we found that 8a minus 12 into I vector minus 6b j vector minus b k vector. This is for del pi 1 at the particular point dot del pi 2 at the point 2 comma minus 1 comma minus 3 is nothing but minus 16 I vector plus 16 j vector minus 27 k vector, that is equivalent to 0. The dot product of these two, del pi 1 and del pi 2 equivalent to 0. So dot product I dot I, that is nothing but 1. So 8a minus 12 into minus 16, right, minus 6b into 16 minus and minus, so plus 27b, k dot k is equivalent to 1, that is equivalent to 0. So multiply these two terms, so minus 16 into 8a, that is nothing but minus 128a, minus into minus plus 16 into 12, 192 minus, right, 96b, product of these two becomes 96, 96b plus 27b equivalent to 0. Simplifying this, we can get 128a plus 69b is equivalent to 192. We named that it as equation 1. Now we are having the equation 128a plus 69b is equivalent to 192. Call it as equation number 1. Here we are having two unknowns. So one more equation we need. That's why, since the point, the corresponding point, what about our point 2 minus 1 minus 3 lies on the surface pi 1 of x1, x comma y comma z equivalent to 0. That's why we substitute the value of x is nothing but 2, y is nothing but minus 1 and z is nothing but minus 3. So pi, what about our pi 1? A x cube minus b y squared z minus of a plus 3 into x squared. Therefore, pi 1 of this point, right? 2 comma minus 1 comma minus 3 is equivalent to a into x cube. So that is nothing but 2 cube. So that value is nothing but 8 minus b into y square, that is nothing but 1, and z value is nothing but minus 3 minus of a plus 3 into that value x square, so 4, as per our condition, that is equivalent to 0. So what is happening now? Therefore 8a minus into minus plus 3b minus 4a minus 12 is equivalent to 0. What is the next step, ma? Therefore 8a, here we are having minus 4a, so 4a plus 3b minus 12 equivalent to 0. Therefore 4a plus 3b is equal to 12. Call it as equation 2. So at present you are having two equations with two unknowns. The first equation is 128a plus 69b is equivalent to 192, and for the second 4a plus 3b is equivalent to 12. At present we are having two equations with two unknowns a and b. Our objective is to find the value of a and b. As usual way, we have to solve these two equations. We can get the value of a is nothing but minus 2.333 approximately, that is nothing but minus 2, right? B is equivalent to 7.1101, that is nothing but 7. These are the values of a and b.